Hello Marshables, welcome back to Marshable Math. Constructions part 2. Sorry, I ran out of tape on the first one. I was in the middle of drawing a little cloud over here with a lightning bolt for Ben Franklin, and I guess that wasn't too important. But anyway, moving on now for constructions. Remember, constructions are geometrical figures that we draw accurately using a straight edge and a compass only. If you're using a ruler, can't use the numbered sides, just got to be the flat straight edge. Now we're on to the one where we construct a perpendicular to a point on the line. So I have a line with a point here called F, and I want to construct a perpendicular line through point F and perpendicular to that line. I've deliberately drawn this one a little short. One of the things that you can do when you're doing constructions is if the line itself, you kind of run out of room or something like that, or maybe F is on the end point of a line, and like, gee, how do I do that? You can always extend the line, right? So I'm going to extend this line a little farther to give myself a little more room to work. So let's try that. All right, so now what I'm going to do is I'm going to take my compass, and it's very similar in idea to the one where we did the perpendicular bisector, or we found the bisector of a line. What we're going to do is we're going to take our compass and we're going to find a location both to the right and the left of F that is the same distance. So I'm going to put my spike here, and I'm going to draw an arc right there, and then without changing it, come over here and draw an arc right there. Needed a little more room. Again, if you were using a standard compass, you would put your spike at F, open it up, you would then make a sweep over here on one side, and then without changing it, you would then make a sweep over there on the other side. Right? Now what do I need? Well, now it's the same thing we did when we had the line segment. I know that F is in the middle point because F is the center of the circle there with the green, right? So I know that this distance is the same as that distance. But pretend I didn't know. If I wanted to now take the line that's between these two sweeps and find the midpoint, I'm going to use that same method. I just know where the midpoint is now. What I want to do is I want to find the top and bottom points to draw my line. So I'm going to take my compass, I'm going to open it up more than halfway. I will then draw a sweep up above and a sweep down below. And then without changing it, I would come over here and reproduce it. Sweep up above. Oops, it slipped a bit. Let me double check. Sweep up above. There we go. And a sweep down below. Yours perhaps is not quite as awkward as mine. Again, if you're using a compass, it would look like this. Spike on the one end where the first sweep was, open it up more than halfway, sweep above and below, then without changing it, move to the other side, spike on the point there where you swept through the original line, sweep above and a sweep below. Now what I want to do is I want to connect this point and that point. That then will give me a line that goes through F that's perpendicular to the original line. So, pencil point on the point, straight edge up against the pencil, match the spacing for the one down there. There we go. That should be perpendicular now. Okay. Yeah, looks that way to me. Oh, but wait! That's not what geometry is about. Geometry is not about, it looks that way to me. Geometry is about certainty. Geometry is not about, it looks that way to me, but about certainty. Yeah, how do I know that this is a perpendicular line? Well, what I've done here is I've actually created a rhombus. By using the compass, what I've done is I've created a figure that has got four sides of equal length. Not necessarily a square. If it had equal angles as well, it would be a square. And so what I've got here is I've got a rhombus, and one of the properties of a rhombus is that the diagonals, these lines that go from corners to corners, they intersect each other at a right angle. So by finding kind of an equal distance here and then finding this here and this here, what I've done is I've made all four sides of this figure equal, and so then this line, this diagonal that goes through it, must be perpendicular to this one. Another property of a rhombus is that the diagonals bisect each other, so I know that this distance is the same as that one, and also this distance is the same as that one. But in the end, really what I'm looking for is I don't need this. That was just kind of extra. You know, that was not part of your tuition. You got that for free. What I wanted was this line right here. Okay? So constructing a perpendicular to a point on the line. Okay. Now, let's extend that a little bit and let's make it a little more challenging. All right, so let me draw a perpendicular to a line from a point that is not on the line. Oh my goodness. These are all just small variations on still the same idea. So again, I've got a line here, I've got a point D. I want to draw a line through D that's perpendicular to this line. Well, again, my trusty string compass. And I'm going to put the spike, or my finger, as the case may be, on D. And what I want to do is I want to find a location on the line that is the same distance from D both times. So in other words, I could draw a big circle around here. That would be okay. But what I want is I want this distance to be the same as this distance. Remember, your compass is what controls your distance. So again, if you're using a compass, you would put your spike at D, and you would open it up and you would make a sweep on one side, and then without changing it, make a sweep on the other side. Okay. Now what I want to do is I'm going to take my compass again, and I'm going to treat this one just like it was that earlier line segment that we're trying to find the midpoint of. But this time I don't have to do a sweep on top and on bottom, I just have to do it on this other side here, this side opposite of D. So I'm going to go, let's see here, more than halfway, and I'm going to come down here and make a sweep kind of in the middle. I'm kind of looking here at D and figuring out where it would intersect, somewhere down here. And then I'm going to come over to this side, and pardon my awkwardness, but there. Sometimes you may find that you've made sweeps and they don't intersect, so that you made this one and it was only like that long, and this one came through and it missed it. Don't be afraid to kind of start over again and make your sweeps as in the right spot. So compass-wise, what I've done is I've taken my spike, put it at the location here on this line, opened it up at least more than halfway. I've made a sweep kind of in the middle here, and then without changing it, put the spike on this side. Hate this thing. Make another sweep there. And what I really want to do now is I want to connect this location with the D. So, instrument down, ruler against the instrument, match the spacing, draw through. Oh my goodness, I missed. I'm embarrassed. Let's see if I can figure out a way to edit that out, but I doubt it. Please be patient. Here. There you go. That makes me feel better. Okay, so construct a perpendicular to a line through a point not on a line. So that should be perpendicular right there. And again, the reason why is I've got myself, those distances are the same, right? This distance here is the same. What have I got? Don't tell me a rhombus. It's another kite, right? So, this is the cross piece. There's where the tail would be. Here's the string. That's terrible. There's, how do you draw like a tri-cornered hat? Something like that, right? And then there's Ben Franklin with his kite. I get to draw my cloud again. Oh, the big old bad lightning. And then what did he have? What was this over here? Key? Did he really get hit by lightning? Maybe that's why he lived to be such an old man. I don't know. Ben Franklin, one of my heroes. Statesman, patriot, scientist, philosopher. He's a good man. All right, next one. Construct a pair. Ooh. I forgot this one was in here. All right, so I have a line AB. I want to construct a parallel line, a line parallel to AB. Notice I didn't just say just draw. I have to construct it such that it must be parallel, given the properties that I give it. This may be a little bit ahead of the lesson for some of you. However, I thought it's important to share here. Off to the side just a little bit. I know that if I have two parallel lines, and we're going to assume that they're parallel for the sake of illustration, two parallel lines that are cut by what's called a transversal. Transversal is just a line that comes in kind of at an angle and slices between them. If I have two parallel lines, and by the way, we show their parallel lines by drawing little single directional arrows on here. So if you see two lines that are drawn like that with arrows that are both pointing the same direction, you can say, oh, those are parallel. Here's my transversal. Comes through at some skew angle there. If I have two parallel lines cut by a transversal, I know through geometry, and maybe you've already proven this, maybe you haven't, but I know through geometry that this angle right here has to be the same measure as this angle right here. These are called corresponding angles. So this angle and that angle are exactly the same. They're congruent if these two lines are parallel. So I'm going to use that principle now, since we already know how to reproduce angles. What I'm going to do is this. I'm going to start with the bottom line, and I'm going to draw myself an angle, and then I'm going to reproduce the angle up here, and then draw the new line. And since the angles are congruent, the lines must be parallel. Okay? So here's what I'm going to do. I'm going to take any old line, and it can be whichever way you want. It can be like that. Please, if you draw it like this, maybe it's a little awkward. I don't know. It could be like this. It's fine. I just don't want it to give the appearance that it's a 90-degree angle when it really isn't. You probably shouldn't, if you're just going to draw a line, you shouldn't draw a line that maybe mistakenly gives the impression that it has properties that it really doesn't. So if you're drawing angles, if it says, hey, draw an angle such and such and such, please don't draw a right angle or one that looks like a right angle, because then it might introduce some confusion to it. So I'm going to draw one that's obviously not a right angle through here like that. Okay, so I'm going to call this point now, I'll be real creative, I'll call it P for point. So now I've got this angle. What I'm going to do is I'm going to come up here and I'm going to pick, I'm going to extend this a bit. I can see already I don't have enough room. I'm going to come up here and I'm going to pick a second point. Maybe I'm going to call that P prime. You'll see why here in a second. Okay, so now I'm going to draw my parallel line through that point. Here's what I'm going to do. I'm going to reproduce this angle right here, up there. So now remember how to reproduce an angle? All I need to do is take my compass and start with an arc. And then come up here and do the same thing. Okay, if you're doing the compass trick, you're going to put your spike at P, you're going to open it up a little bit below this value, and you're going to draw your arc, and then without changing it, come up here to this point, and then draw your arc again. Make it big. I mean, you can go a full circle if you wanted to, but it can't be too big, it can't be too small. Now what I need to do, and I'll do this with the compass itself rather than the string, because you really have to see this technique here. What I'm going to do is I'm going to put my spike, how should I do this? Here, I'll do it this way. Before, when I did the reproducing the angle, I kind of put the spike at the bottom and I came up here and I found that location, right? But I can't do that on this side because I don't have the bottom line. What I've got is I've got the side line. So what I'm going to do is, I'm going to come over to this side. I'm trying to find the best way so you can see it. I'm going to put my point here, and without moving it, I'm going to open up my compass up so that it exactly matches where this arc intersects the original line. So I'm going to place it. Is that it right there? Oh my goodness, look at that. First try. Okay, now without moving it, I come up here, place it, and then find the identical intersection point. Follow that on there? It's upside down from the way we did it previously, but you should be able to manage it. Now you should know what we do, right? I'm going to connect this location and that location right there. See if I can do it without messing it up this time. All right, do it down below. Okay, so take my pencil point there, rule it up. There we go. Does it look parallel? I think so. Here's one of the ways we could check. Isn't it true that the distance between parallel lines always is the same? So if you wanted to check it, we're going to do something outside the bounds of constructions. If I take now my ruler with the measured part and I find the distance between the two of them, it looks like, ignore the shadow there, it crosses right at about 24 centimeters. If I come back over here, does it still cross at 24? Is it, woohoo! Yeah! Got it. Okay, good. So what we're going to do then, as a reminder, we'll draw a transversal, okay? We will then duplicate the angle here, up here, and then because the property that corresponding the angles are congruent if the lines are parallel, then I know that the line through here, for this point, the bottom of the base of that angle, must be parallel to the original AB. I kind of like that one. That one's fun. This one's actually used when we do things, well, I'll get into that later. Never mind. Too soon. Shh. Not done, buddy. Jumping ahead a little too much. Oh, yeah! Okay, so challenge. One of the challenges I've got for you now is to see if you can use what you know in order to construct a 60-degree angle. And no, I don't mean by getting a hold of this tool. That's not a construction tool, right? Oh, I protract 60 degrees. No, that's not a construction, okay? This has got a graduated kind of a line to it here. This is a measurement device, not allowed in construction. It's got to be theoretically 60 degrees. How do you draw an angle? Dang it, gave you a hint right there. How do you draw an angle that's 60 degrees? Think about it. I'll wait until it gets just a little bit awkward. See, the thing about constructions is oftentimes we want to do the construction, or we want to think in terms of geometry just straight away to what we want. Well, I don't know a construction pattern that gives me a 60-degree angle, therefore I can't do it. What we need to be thinking of is what things can we draw that might have the property of having a 60-degree angle? Because if we can then construct it, then we've got it, right? Just like the kite there, or the rhombus for those previous ones, right? What I was really doing is I was drawing a rhombus, or I was drawing a kite, or I was drawing a triangle. Remember I almost said triangle a second ago? Yeah, there's a way that you can draw a 60-degree angle kind of as a side product of drawing a particular kind of triangle. What kind of a triangle can you draw that's got a 60-degree angle? You could draw a 30, 60, 90 triangle. If you could do that with constructions, I'd be impressed, because that's not the way I would do it. If you figure out a way, like put it in the comments down below the video, or send me an email or something like that, I'd be interested in seeing that. Is there a triangle that I can draw that's guaranteed to have a 60-degree angle? Yeah, an equilateral triangle. How do you draw an equilateral triangle? Well, you use your straight edge. No. Equilateral means equal side lengths, right? What tool do we use that controls length? The compass. So how do we use a compass to draw an equilateral triangle? Because if I can draw an equilateral triangle, I know that one of the angles, in fact, all of the angles, are 60 degrees. Well, I got to have some side length, right? So let me do this. Here's what I'm going to do. Maybe you should pause the video at this moment and go try it yourself. I don't want to steal from you the joy and the satisfaction of being able to figure it out on your own. So pause it for a bit, wrestle with it. maybe even like come back tomorrow. You know, you can work on these problems for longer than a day. I'm not going to take the video down after you start to watch it. So pause it. See if you can figure out how to draw an equilateral triangle. Are you back? Good. If you tried something, I'm proud of you. Okay? Take a step. Even if you're not quite sure where to go. You're going to be brave enough to move forward. Here's what I'm going to do. I'm going to start with some length. Doesn't matter how long. Right like that. Now, I'm going to use my compass then to match this length, like I would be reproducing a line segment. So I'm going to come over here and extend it. Nope, too short. Right there. And I'm going to do an arc above. And without changing the distance of the compass, come over here and switch the spike at the other point. Do an arc over here. Can you see that this is one side of a triangle? This is one side of the triangle? Right? When you look at it now, maybe you're like, oh, that's so simple. How come I didn't see that? Well, it's creative. And just like, you know, when you write a book report of a book that's already written, that's a whole lot easier to do than actually writing your own book. Sometimes these constructions are very, very creative and it's difficult to produce them. But the more practice you have at it, the more you get the feel sort of how to do these things. And then so if I connect this location here, oh, it slipped, knew it. Yeah? Oh, do I have to draw the other side? I guess I don't, right? I'll do it just for giggles. Poor guy, the unneeded side. So sad. Yeah, doesn't this have to be a 60-degree angle? Exactly. It does. Because if these sides of the triangle are all equilateral, which they are because we control them with the compass, then there's a principle that says, oh, the interior angles all add up to be 60, and if the sides are all equal, then the angles are all equal. And 180 divided by 3 is 60. But just to be certain about it, we'll line it up right there. 60. Woohoo! Here's the thought. I'll leave you with this. And I'm not going to do this one. You'll leave it up to you. How would you construct a 30-degree angle? 30 degrees. And after you have figured out how to draw a 30-degree angle, how would you construct a 75-degree angle? 75-degree angle. If you watch both construction videos, you should be able to now formulate a plan for doing that. Give it a try. See if you can do it. Notice I said you can't do the 75 until you figured out how to do the 30 because the technique is related. Okay? So, I hope you learned something. I hope you're enjoying life. Remember, geometry is good. Music, geometry, arithmetic, and astronomy, the 4 mathematical arts of the quadrivium. It's one of the things that is essential for human beings, right? So mathematics is not just for mathematicians. Mathematics is for everyone. Have a great day.